Hi everybody. Today we're going to go over section 5-6, the remainder and factor theorem. We have already talked about some of this, so it should look familiar. When we were graphing polynomials, I had you use synthetic division to find the y values when x equaled what you divided by. So that's what we're going to be doing today as well. So I'm going to read through some of the notes and then we will go over some examples. Starting here at the top, synthetic division is a shorthand method of long division. The last number is the remainder. Synthetic division can also be used to find the value of the function at that given point. If the remainder is 0, then the divisor is a factor of the dividend and the graph intersects the x-axis at that point. If synthetic division is used to evaluate the function, it's called synthetic substitution. So for example, f of x equals 2x to the fourth minus 5x squared plus 8x minus 7. And we want to find f of 6. What we have done in the past is called direct substitution, where I substitute a 6 in for every x value. So it would look like this. Okay, so I just substituted a 6 in for every x, and after evaluating, I get that f of 6 equals 2,453. So in other words, when x is 6, y is 2,453. It makes a point on the graph. Okay, so today we're going to use synthetic substitution. So that means I'm going to divide by 6 because I want to divide by what the x is. And I'm going to line out my coefficients. I have to put a 0 for the x to the third. Okay, and then I'm going to bring down my first term. I'm going to scoot this up a bit. So that's 2. 2 times 6 is 12. Add those together, that's 12. 12 times 6 is 72. Add those, that's going to be 67 because they're opposite signs. 67 times 6 is 402. Add 8, that's 410. 410 times 6 is 2,460. Subtract the 7 because it's an opposite sign, you got 2,453. So you get the same value for y either way you do it. That is also a point, the same point that we got before. Okay, so let's move on to the next part. Let's say we have this polynomial, x to the fourth plus x to the third minus 17x squared minus 20x plus 32 is divided by x minus 4. So I'm going to divide synthetically. That means I want to divide by 4. Okay, my coefficients are going to be lined out. I don't have any that are being skipped, so I don't need to worry about putting a 0 in place of anything. Bring down my first term. It's going to be a 4. 4 plus 1 is 5. 5 times 4 is 20. Negative 17 plus 20 is 3. 3 times 4 is 12. Negative 20 times, or plus 12 is 8. 8 times 4, oh, that's a negative 8, sorry. Negative 8 times 4 is negative 32. 32 minus 32 is 0. So we got no remainder on that one. That means my polynomial, my quotient, is x to the third plus 5x squared plus 3x minus 8. And this is called the depressed polynomial. That's an N-O-M. Sorry, I cannot spell. I know it's kind of depressing doing all this math all the time. So that polynomial gets depressed too. And when you find a quotient, they call that the depressed polynomial. So that's a term that you're going to need to remember for future use because we're going to be using that a lot in class. Okay, so since the remainder is 0, then what I divided by, x minus 4, is a factor of the polynomial. That means that this graph right here, if we were to graph that, either on the calculator, by hand, whatever, it would cross the x-axis at 4. And that's the factor theorem. That's what's called the factor theorem. So x minus 4 is a factor of a polynomial function if f of 4 equals 0. Except they use a generic number. They use a instead of the regular number. Okay, so let's do some examples. Number 1 says, show that x plus 3 is a factor of x to the third plus 6x squared minus x minus 30, and then find the remaining factors. All right. So I'm going to divide by negative 3. Since the factor is x plus 3, when I solve that for x, it's negative 3. I'm going to write down my coefficients out here to the side. None of the degrees are being skipped, so I don't need to worry about putting a 0 in place. Okay, bring down my first term. 1 times negative 3 is negative 3. 6 plus a negative 3 is 3. 3 times negative 3 is negative 9. Negative 1 plus negative 9 is negative 10. Negative 10 times negative 3 is positive 30. Negative 30 plus 30 is 0. Okay, so that is how you show that x plus 3 is a factor. You just show that your remainder is 0. You divide synthetically, show that the remainder is 0. So the depressed polynomial here is x squared plus 3x minus 10. Okay, so they also want me to find the remaining factors. So to do that, I just need to factor my polynomial. Okay, take the leading coefficient times the constant, that's negative 10. 2 factors of negative 10 that add to be a positive 3. It's going to be positive 5 and negative 2. So I'm going to use those 2 factors to expand the polynomial. That's going to be my middle term. Plus 5x minus 2x, negative 10. So all I did was I expanded the middle term using the 2 factors that I got. And then I can group and factor. So the first 2 terms have an x in common. I have x plus 5 in parentheses. The last 2 terms have a negative 2 in common, and I have x plus 5 left in parentheses. I have identical binomials, so now I can consolidate x minus 2 together and write x plus 5 one time. And these are the remaining factors. That's the second part of the problem that they're asking for. So x minus 3, or I'm sorry, x plus 3 is a factor, but then so are x minus 2 and x plus 5. So to get remaining factors, you need to divide synthetically, get the depressed polynomial, and try to factor if you can. Okay, so now let's take a break, and you guys go get a drink of water, whatever, come back, look at part 2. Part 2 is going to be really short, so as soon as we're done with that, then we'll be good to go for tomorrow. See you in a little bit.